Alright, now we'll try to describe the object using the displacement time graph as comprehensively as we can. So I've isolated two coordinates here. One is time at 0, and the other one is time at 5 seconds. Now you notice that when time increases by 5 seconds, the displacement increases by, the displacement decreases by 10 meters. So when time increases from 0 to 5 seconds, the displacement decreases from 30 to 20. 30 to 20, alright? So when t increases by 5 seconds, the displacement of the object decreases by 10 meters. Note that I have the minus sign here. We'll talk more about that later. Right, so don't worry about the minus sign yet. So when t increases by 5 seconds, the displacement of the object decreases by 10 meters. Therefore, when t increases by 1 second, the displacement of the object decreases by 2 meters. Right? Decreases by 2 meters. Okay? So, we learned that displacement refers to distance covered in a specific direction. Alright? So when the displacement decreases, it merely means that it's moving closer and closer towards its origin. Right? So you see it decreases by 2 meters, moving towards its origin. Okay, moving towards the origin, right? Now that's not all. Okay, that's not all. Because when you look at the graph, you realize that the graph is a straight line. Right, it's a straight line graph. Okay, so that means the gradient is constant at all points along the graph. Right, the gradient is constant at all points along the graph. Okay, and it can show you a quick one to show you how is it constant. Right, we know that gradient gain back in the lower sec is rise over run. Now let's choose these two coordinates when time is 0 and time is 5 seconds. This is your run, and 5 minus 0 equals 5 seconds. When time increases from 0 to 5 seconds, the displacement, that's your rise, decreases from 30 to 20 meters. So we always take final minus initial, and that's 20 minus 30, this is minus 10 meters. Right, final minus initial, so minus 10 meters. Don't worry about the minus sign, just leave it there first. And that's minus 10 meters over 5 seconds. You get minus 2 meters per second. How about I choose another set of coordinates? And this time round, we choose a bigger triangle. and that is here. And this is the run, which is 10 minus 0 equals 10 seconds. And this is the rise. So the displacement decreases from 30 to 10. That's 10 minus 30 equals minus 20 meters. And your gradient equals rise over run equals minus 20 over 10 equals minus 2 meters per second. You get back the same gradient. And that proves the point. The gradient is constant at all points along the graph. So how do we describe the motion of this object in a more comprehensive manner? The displacement of the object decreases at a constant rate of 2 meters moving towards its origin for every 1 second. Right? Constant rate. Okay, this is very critical. All right, constant rate, straight line graph. So when you say constant rate, you are actually implying a straight line graph. Right? So let's say again, the displacement of the object decreases at a constant rate of 2 meters moving towards its origin for every 1 second.